This video is going to give a brief overview of the mean value theorem for derivatives. It is section 3.2 in our books, and I would like you to take notes on what you see in the slides and any examples that I may do out. So the mean value theorem says that if you have some continuous function over a closed interval from a to b, and that function is differentiable over the open interval a to b, then at some point c, which would be an x value, between your interval a and b, the slope from a to b, which would be the secant line that connects your points from a to b, that slope would be equal to an instantaneous slope at that point c. Okay, so the slope of the secant line will have to be equal to the slope of some tangent line at c. It's much easier when you have a diagram to look at, which I have on the next slide. I should have also mentioned that the mean value theorem is a really important theorem in calculus, so we'll be using it throughout the year to prove various things. Okay, there's a lot going on this slide, so let's start looking at it. Up here is the mean value theorem, as I just explained it on the previous slide. If you take a look at the right-hand side, you'll notice that this is just the slope formula for finding the slope between 2 points. And my 2 points, if you look down at the graph, are the x value is at a and the the other x value is at b. And so I have these 2 points up here. So this is the point a comma f of a, and this is the point b comma f of b. And so the slope, which would be the slope of this line right here, would be this formula. That slope, if you go back up to our formula up here, has to be equal to the derivative at some point c. So somewhere on this continuous graph, I'll have to have a tangent line that's parallel to this slope, okay, at some point. So in this graph, it happens to be right here, but it could happen at any point, okay? And so you can see that here's my tangent line at c, and it is in fact parallel to my secant slope. So that's what's going on this graph. Let's look at an example. So we're supposed to decide whether the mean value theorem applies to the given function on the given interval. So in order for it to apply, I'm going to just make this a little smaller here so I can write below it. In order for it to apply, we have to have our function be continuous, which it would be because this is just parabolic, it's a quadratic, and it also has to be differentiable on the interval as well. And a parabola is differentiable everywhere, so it's definitely differentiable on this interval from -2 to 2, the open interval from -2 to 2. And so the mean value theorem can apply, which means that there must be some value c where the slope of the tangent line at that point would be equal to the slope of the secant line between a and b. So let's go find the slope between a and b, which is going to require us to find the y values associated with -2 and 2. Okay, so I found my 2 different points, -2, 2, and 2, 6. And actually it would be helpful if I had a graph to look at, just so we can see that the secant line is actually going to be parallel to some tangent line at our point c. And then we'll go find that point c. Okay, so here's a graph of the parabola. I'm going to actually plot the points -2, 2, which would be about here. It's a little hard with this. And 2, 6, which is about here. And now I'm going to connect those 2 points so we can visualize what the slope will be. So here's the secant line, and what the mean value theorem is saying is that there's going to be some point c along this parabola here, within these 2 values, that's going to have a tangent line that is parallel to this. So if I were to just approximate it, I would think it's going to be about down here somewhere. So my approximation is that the tangent line should be somewhere here. Okay, but now we can go and actually find that value c. So to do that, we have to now go use this formula. So I'm going to first calculate the slope, then I'm going to calculate the derivative, and we'll see where we are then. So using the slope formula, I would have 6 minus 2 over 2 minus -2, which would equal 4 over 4, which is 1. So the slope of this line that I've drawn in here is 1, and so we're looking for a tangent line slope that would also be 1, and we want to know at what x value does that occur. So we should next find the derivative function. So I need f primed of x, and for this function up here, that's pretty easy. It would be 2x plus 1. So that's our derivative function. And this, remember, will tell us the derivative at any point. We're looking for our point, but we know that we want this slope to be 1. So I'm actually going to now set this equal to 1, and then I'll be able to solve for the specific c value. And so if we solve this, I think you're going to see that x is 0, which means c is 0. And if you look at my graph, actually, where I've drawn the tangent line in, where that would have a slope that's parallel to this secant line, that does look like it's occurring at an x value of 0. So again, the mean value theorem was assuring us that on this closed interval -2 to 2, there would have to be at least one point, at least one value c, where the slope of the tangent line at that point would be equal to this secant line slope, at least one point. Now it's telling me to find all values of c, but we only came up with one value, and I think you can see from our graph that there is only one tangent line on this graph that would be parallel to this line. So we have found the value of c that would satisfy the mean value theorem. I'd like for you to actually try this next problem yourself in your notes. You're basically doing exactly what I did on the previous slide. You don't have to graph it, although if you want to graph it to see a visual, you can. And so you're supposed to first show that the function satisfies the criteria for the mean value theorem on the closed interval -1 to 1, and then if it does, which it should if you're showing, then find c. So you can work that one out. And on the next slide, the last slide, I'm just going to briefly show you Rolle's theorem. Okay, so Rolle's theorem is basically a specific case of the mean value theorem. On Rolle's theorem, your a and b values that you have, the f of a and f of b are actually equal. So you're basically dealing with a slope of 0. So that's what it's saying. It's basically the mean value theorem, but now your f of a and your f of b are equal, and it's saying that there is at least one number c in AB such that f primed of c is 0. So basically, if you're connecting two equal y values, there's going to be another point within that interval, so here, where the slope would have to be 0. Pretty self-explanatory. That's Rolle's theorem. I hope this video was helpful, and I will see you tomorrow in class.